Now we're going to learn the rule for the derivative of exponential functions. So it says the derivative of f of x equals b to the x is f prime of x equals b to the x natural log of b. Okay, so here's our rule. And so we can do an example. And if our f of x was 2 raised to the x, then our derivative would be 2 to the x times natural log of 2. And remember, natural log of 2 would just be a number. So this would be a number times 2 to the x. So our first question is what does this make the derivative of e to the x? Well, if we just look at the formula, f prime of x would be e to the x natural log of e. But what is natural log of e? Well, natural log of e is just equal to 1. So our derivative of e to the x is e to the x. It's itself, which is pretty remarkable. What we're saying is at any point, the function is changing at the exact same rate as its y value at its point. And that's why this is used for exponential growth. But a way I like to remember this is if you have e, it's easy. Okay, the derivative of e to the x is easy because it's just itself, e to the x. Okay, so let's do a couple of problems here. It says find the derivatives of the following functions. So first we have f of x equals 6 to the x. So that's just using our rule. F prime of x will be 6 to the x natural log of 6. Okay, 2 here says g of x is 7 to the x plus e to the x. So we'll take the derivative of 7 to the x, which would be 7x natural log of 7, plus the derivative of e to the x, which we know is easy, just e to the x. And our last one here, we have h of x equals 15 e to the x. Well, remember our constant multiple rule. We can just leave that 15 alone, take the derivative of e to the x, which is e to the x.